So this problem says to use the definition of the derivative to calculate the derivative of f of x, where f of x is 6 over x plus 1. First of all, to do this problem, we need to know what the definition of the derivative is, and I like to use the form of the limit as h approaches 0 of f of x plus h minus f of x over h. So using this definition of the derivative, the first thing I like to do is to plug in my, or to identify my f of x plus h. So my f of x plus h is my original function, but every time I see x, I'll plug in x plus h in for that. So I'll make it 6 over x plus h. I'm writing that instead of just the x, and then plus 1. Once I find my f of x plus h, I want to simplify this function as much as I can before I plug it into the overall definition of the derivative. But this problem, we don't have any terms that we can combine on the bottom. I think this is pretty much as simple as it's going to get before we plug it into the definition. So plugging into the definition, let's do the limit as h approaches 0 of our f of x plus h is what we just found, is the 6 over x plus h plus 1, and then minus f of x is just the exact function that we were given, 6 over x plus 1, and then we divide all of that by h. So from here, in order to take our limit as h approaches 0, we would basically just plug in a 0 for h. We can't do that at this step because we have an h in the denominator. That would make the denominator go to 0, which is undefined. So what we need to do is we need to simplify this expression until we can cancel the h out of the denominator. So a typical method to do that when we have fractions in the numerator is to find a common denominator and add those fractions together. So there's nothing common, or there's no common factors of x plus h plus 1 and x plus 1, so we can just multiply those two denominators together. Let me write that out down here because it'll take a bit of space. The limit as h approaches 0 of, we need to multiply x plus h plus 1 by x plus 1, so we need to do that on top and bottom. That will look like 6 plus x plus 1 over x plus h plus 1 times x plus 1. And we can do a similar idea by multiplying this top and bottom of the fraction by this denominator. So that will make 6 times x plus h plus 1 over the common denominator. And we can write all that over h. So from here, I know this is going to be kind of long, so just bear with me. From here, we need to distribute out the numerators of our fraction, but I find it easier to leave the denominator in the factored form. So let's write that as the limit as h approaches 0 of 6x plus 6 minus, and that would be over x plus h plus 1 times x plus 1. Then distribute this guy out as well, 6x plus 6h plus 6 over our common denominator, all over h. Now that we have distribute out the numerators, we can subtract our two fractions, and make sure that you distribute this negative to every term in the second numerator. So that'll make the limit as h approaches 0 of 6x plus 6, and then minus 6x minus 6h minus 6. So this is a really common error, is to not distribute that minus to every term, so be careful that you do that. All over the common denominator, and then all of that over h. Okay. From here we can combine some like terms. We have a 6x and a minus 6x, so those two can cancel. We have a plus 6 and a minus 6, so those two can cancel. And that leaves us with the limit as h approaches 0 of, the only thing that's left on the numerator is negative 6h, and then the common denominator stays the same. X plus 1 all over h. Okay, now that we have combined our fractions into one fraction and simplified that, we can use the formula of a complex fraction that if you have a over b over c over d, we can simplify that by writing it as a over b times d over c. And since the main fraction bar, like from the original problem, was this over h, we can write the h as over 1 to make the numerator fraction be this top part and the denominator fraction be this bottom part. So let's leave the top fraction the same and flip over the h over 1. And a common way to say that is to keep, change, flip, because you're keeping the top fraction, change the division into multiplication, and then flip the bottom fraction or find its reciprocal. So that would be the limit as h approaches 0 of negative 6h over x plus h plus 1 times x plus 1, and then times 1 over h, the reciprocal of h over 1. All right, from here, now we have a factor of h both in the numerator and the denominator. So this will cancel, which is what we were trying to accomplish from the beginning. We were trying to get that h out of the denominator so that when we take the limit and make h equal to 0, that it doesn't make the entire denominator go to 0. So at this point, we can, let's just rewrite the limit as h approaches 0 of negative 6 over x plus h plus 1 times x plus 1. And we can finally now do that substitution of making h equal to 0. And this is the step where we don't have to keep writing that limit, because once we do the substitution of h is 0, then we can just drop the limit. We can make that negative 6 over, the h goes to 0, so it would be x plus 1, and then times another x plus 1, which we can write as the x plus 1 in the denominator, we can write that as being squared. So negative 6 over x plus 1 squared, and that would be our derivative. So I hope this step-by-step solution was helpful for you. If it was, please like the video and also subscribe to my channel to see more homework help solutions such as this one. If you have any questions, feel free to leave those in the comments, or if you have a homework problem that you would like to see a video on, feel free to leave that as well, and I'm doing as many of these videos as I have time for. Happy studies, and thanks for watching.